Hi everybody, Olivia Murphy and Savannah Mertens here to teach you 4.1b negative exponents. Okay, let's begin with a review of the laws of exponents. All of these still apply when dealing with negative exponents. So the zero law states that any term to the power of 0 equals 1. For example, 5 times 6 times 200 times 11 to the power 0. So anything in this box to the power 0, anything that would be in there, that would be 1. And then 5 times 1 equals 5. When combining like terms, which is adding or subtracting, with like bases and exponents, add or subtract the coefficients. So we got 3x6 plus 7x6, that would equal 10x6 because the base and the exponents are all the same. We just add the coefficients. Alright, addition, which is more like multiplication. When multiplying terms with like bases that have exponents, add the exponents and do nothing to the bases. So we got x4 times x6 equals x10. And if you have coefficients, multiply them like you normally would. See? Alright, so subtraction is pretty much the same as addition, except, division. So when dividing terms with like bases that have exponents, you subtract the exponents and do nothing to the bases. So say we got z12 over z6. That would equal z6 because you just subtract 6 from z12 and you get that. You could also do it the other way around and have the 6 on the top and the 12 on the bottom, and that would just equal 1 over z6. If there are coefficients, divide them, sorry. So say we got 8z12 and 4z6. You divide 8 by 4 and that would equal 2z6. Okay, let's move on to multiplication. When a base with an exponent is exponented, or taken to a power, multiply the exponents. So we got y3 taken to the 6th power equals y18. Note in the problem, say 4z minus 1 squared, you don't distribute. This is the whole base. So it'd be 4z minus 1 times 4z minus 1, not distributing to the 4z into the negative 1. Alright, distribution. A term outside the parentheses with no other operation sign is to be distributed or multiplied to all terms inside the parentheses. So we have 5, 3x minus 2, simple enough, just distribute. Let's say we have exponents now. You got 5x6, 3x2, negative 9. So if it has exponents, all the rules still apply that we just learned. So that'd be like 15x8 because we're just multiplying minus 45x6. Okay? Now we are finally to our 4.1b negative exponents. Let's begin with a few key reminders. Just because the exponent is negative does not mean the number or base is exponent, okay? And an answer should never have a negative exponent in it. Alright guys, if you box that and say that's my answer, that's wrong. Alright, now we will explain how to solve the negative exponents to make sure there is not a negative exponent in your answer. We are going to start with the numerators. So any base in the numerator with the negative exponent needs to be moved to the denominator. So say we have y negative 6, well that needs to go to 1 over y6, okay? Pretty much the same thing for the denominators. Any base in the denominator with a negative exponent need to be moved to the numerator. So we got 1 over y negative 6. We just move the y6 up, put the 1 there, or we can just leave it y6. Okay, if there are parentheses around the base, exponent, and coefficients, then they all need to move. So say if we have 1 over 4y negative 6, then you move this all up, you get 4y 6 over 1. Oops, didn't mean to do that. Okay. But if the parentheses are only around the base and the exponent, actually you don't even need the parentheses right there. You only move the base and the exponent up and not the coefficient. So it would be x6 over 4. Alright? Alright. Now we're going to do some examples and try on your own, and Savannah's going to take over and help y'all out.
Okay, let's do the example. So, if you have z negative 5 times z to the 7th, it would actually be like this, z7 over z5, because that gets rid of the negative. That would equal z squared. Go ahead and try this one on your own. 1 over 10 x to the negative 4. This is equal to x4 over 10, because you bring this x with the negative 4 up here, and the 4 turns positive. Let's try another example. 9 to the negative 6 times 9 to the negative 2 over 9 to the negative 3. This turns into 9 to the 3rd over 9 to the 6th times 9 to the 2nd. This simplifies down to 9 to the 3rd over 9 to the 8th, which in turn can simplify down to 1 over 9 to the 5th. Let's try this on your own. 8 over 4 to the negative 5th equals what? Okay, this can simplify down to 4 over 8 to the 5th. You got rid of the negative. And that equals 4 to the 5th over 8 to the 5th. And you don't want to simplify down anymore, because otherwise then you just get numbers and it gets really nasty. So this is your final answer. Let's try another example of that. 3y to the negative 4th. That would turn into 1 over 3y to the 4th. Whoop. That distributes into 1 over 81y to the 4th. That is your final answer. Let's move on to some slightly harder examples. So, 6x to the 3rd, y to the negative 2, to the power of 2, times 5x to the negative 1, y 4 to the 3rd. This turns into 36 x to the 6th y to the negative 4th times 125 x to the negative 3rd y to the 12th. This simplifies down to 4, 5, 0, 0, x to the 6th, y to the 12th, over y to the 4th times x to the 3rd. This can be simplified down again into 4, 5, 0, 0, x to the 3rd, y to the 8th. Let's try one on your own. Six x squared y to the 4th, whoop, that is a 4, to the negative 3rd times 3 x to the negative 2 y to the negative 4 times, or to the 3rd power. See what you get from this in just a few seconds. Okay. What you should get from this is 1 over 6x squared y to the 4th to the positive 3rd times 3x to the negative 6 and y to the negative 12. This turns into 1 over 216 x to the 6th y to the 12th times 3 over x to the 6th y to the 12th. Your final answer is 3 over 216 x to the 12th y to the 24th. Good job, guys!
Thank you for watching!